Hello everyone, this video is about equating coefficients and algebraic manipulation when finding the factor or when doing algebraic divisions. Equating coefficients, it's an alternative to polynomial long division but faster, only applicable when dealing with low order polynomials and factors. Factors means without remainders. So for example, here we have x cubed minus 2x squared minus 3x plus 10 divided by x plus 2. So yeah, we gotta get x squared. It's gotta be quadratic here, of course. It's gotta be x squared because when we multiply we get x cubed. And for the constant term, this must be plus 5 because that's the only way we can get plus 10 plus 2 times plus 5. So now we don't know this term in the middle, so something with x. So we can just maybe for now call it plus kx. And if we try to find this term or this term here, so to get the x squared term, that is from 2 times x squared, so that's 2x squared, and we can get x squared from x times kx, so plus kx squared, but it's supposed to be minus 2 on the left, so this is supposed to be minus 2x squared. So that means the k is gotta be minus 4. Or we can also use the x term. So from the right hand side, the x term, the term with x, is when we do 2 times kx, so we have 2kx, or from x times 5, so 2kx plus 5x, that's all the terms with x on the right, and on the left the term with x is just minus 3x. So since this is 5, this whole thing 2k must be minus 8, which means again the k is therefore minus 4. So there you have it, the k is actually minus 4. So we get the factor. Algebraic manipulation, it's an alternative to polynomial long division but faster, applicable when dealing with low order polynomials, so we can only use it for the easy divisions. Express the numerator in terms of the denominator. So this is the key here. We somehow manipulate the numerator so that it is in terms of the denominator. So in this case the denominator is x minus 3, so we rewrite the numerator as x minus 3 plus 2. Yep, because this is still x minus 1 actually, divided by x minus 3. And as you can see, we can split the fraction x minus 3 divided by x minus 3, and we still have 2 divided by x minus 3. So it's 1, that's the quotient, the remainder is 2. Alright, last example. So we are expressing this in terms of x plus 1. So as we have a square here, let's expand x plus 1 all squared. That's x squared plus 2x plus 1. So that means if we want to express the numerator in terms of x plus 1, we gotta make it 2 times x plus 1 all squared. From here, this is what we get multiplied by 2. So we have 2x squared plus 4x. So plus 4x, but originally we have plus 7x. So we still have to add 3x. And remember, we multiply by 2 here, so it's 2 times 1, that's 2, but this is actually 7 originally, 9, so we need to add 7. Okay, so that's one step closer. And now we express this x here also in terms of x plus 1. So 3 times x plus 1. So we get 3x plus 3, which means we still have to add 4 so that we're not changing the value. So if you expand everything in the numerator, you will get exactly the same expression here. So divided by x plus 1, of course, from this divided by x plus 1, we have 2 times x plus 1. So we have 2 times x plus 1. And from this divided by x plus 1, we have 3. And for this part here, nothing to simplify, it's just the remainder, plus 4 over x plus 1. Of course, we can also rewrite this as 2x plus 2 plus 3, so plus 5, plus 4 over x plus 1. Right, that's it. I'll see you again next time.